Welcome to Digital Communication Tutorials. Today we are going to discuss tutorial Sheet-6, which is about convolutional codes. So I am starting with question 2, in which we have to draw the state transition diagram and Trellis diagram. These two things are very important for the convolution encoder. Okay, so we are starting with this. So this is the question where two flip-flops are given, two modulo adders are there. They are generating a code corresponding to the input data, right? So for 1 bit, it is generating 2 bits of code, right? So it's we can say 1 by 2 encoder. Code rate is 1 by 2. Okay, and this mux is just serializing that data. Okay, whatever the code are generated, it is serializing that. So now see how we can solve this problem. Okay, so first we will draw the state transition diagram, then Trellis diagram. So I just copied this in a separate sheet. Okay, so first we have to represent this diagram in terms of equations, as previously I discussed, because once you represent diagram with the help of equations, you can easily trace the output, right? Whatever the change in the input or states you have, so easily you can draw the table. Okay, so here I am representing data bit D. Okay, so I am considering variable D here, and Q naught is the output of second flip-flop, and for first flip-flop is Q1. Okay, so we have to write the equation for C1. C1 is the code word, right? For C1, so C1 is the combination of these three. Okay, so we can write D modulo 2 with the Q1 modulo with Q naught, right? So here you can see Q1, Q naught is here, Q1 is here, and D is here. Okay, in the same way, C naught is Q naught and D. Okay, so I can write D modulo 2 with Q naught. Okay, so now we have the equations. With the help of these equations, now you can form a table, and that table will help to draw the state diagram. Okay, so for the table, I write input, which is represented by D, and I write present state. As in digital, we do whenever we have the registers, we write the PSNS table, right? So in the same way I'm writing. So present state, I write Q1 and Q naught, and next state, I write Q1 dash, Q naught dash. Okay, and then encoder output, right? So encoder output is C1 and C naught. That we have to write. Okay, so now what are the possible states? So here we have the two flip-flops, right? So two flip-flops, so possible number of states we know it is 4. So 4 states are possible, like 0 0, 0 1, 1 0, and 1 1. Okay, like this. So input is either 0 or 1. So corresponding to that, we can write input and PS. Okay, so I write if input is 0 and state is 0 0. If input is 1, again state is 0 0. Input is 0. Now state I take 0 1, 1 0 1. Okay, now message 0, state is changed to 1 0. When message 1, it's 1 0. When it is 0, 1 1, and when 1 1 1. Okay, so for each state, message input message may be either 0 or 1. Okay, so and here we are alternatively changing this. So here no need to make the binary, right? Here we are not going to solve K-map, so don't you worry. Yeah, we have taken this not in sequence, so don't worry about that. Okay, now we have to decide the next state. So here next state is very easy. What is the next state? When suppose I'm entering here I'm providing some data. Suppose I provide here 0, right? Initially it is 0 0, it's 0 0. So when you will feed this data, what will happen? This 0 will store in this flip-flop, and this 0 will store here. It is shifting basically. Okay, so next state here will be 0 0. All are 0. Next time we feed here 1, right? Now message is 1. So this one will shift into the first this one will shift in this flip-flop. Okay, it is shifted here, and whatever 0 is here, it is shifted here in second flip-flop. Okay, so now state is 1 0. I hope it is clear. Simply what we are doing, whatever input we are having, we are shifting that, right? So out of these 2 bit, 1 bit shifted here. So first will shift to this Q1, shift to the Q0, and message bit shifted to the Q1. Simply, you have to shift in the same way. So I hope it is clear. Okay, so I just clear here. Okay. So in the same way, I can write other states. So here, what is 0 shifted here? So now it becomes 0 0. Nah? So the rightmost bit disappear, and you are considering only 2 left bits. You can consider like this. It's a 1 0. It's 0 1. It's shifted basically. It's 1 1. It's a 0 1, and it's a 1 1. Okay. Now you have to find the encoder outputs. So we have equations. So by using these equations, you can easily write C1, C0. So C1, so you have to take the, so this C1 and C0 you will find with the help of present state. Okay, not next state. This next state will be helpful in drawing the state, state diagram. The state diagram we require present state and next state like that. So in that case it is useful. But finding the output, you require this message, this input data, and present state. Okay, so here obviously all 0, so we are getting 0 0. Okay, so in next it is a all modulo you will do. So C1 is 1. Okay, and C0 is D and Q0. So you can check D is 1, Q0 is 0. So again it is 1 1. Okay, then here all 3 in C1, all 3 are added, right, as a modulo 2 adder. So it is 1 C1, and for C0 D and Q0. So D is 0 and Q0 is 1. So again is 1. Okay, after that 1 in this case you can check. So now 2 ones are there, so it is 0, and D Q0 again it is 0. Okay, so in this way you can complete this table. Okay, now this table is completed. Now you have to draw a state diagram. Okay, so for that what you have to do, for that we have to assign, you studied earlier in digital state assignment. Okay, so whatever the binary value we have, corresponding to that we assign some alphabet, right? So for this, suppose I assign it as so 0 0 assigned with A, right? 0 1 is with the C, okay, and 1 0 with the B, and 1 1 with D. So I consider this assignment according to Gandhi sir book. Okay, so so you can cross verify the question. Otherwise you can give any assignment, and it is not necessary, right? So it is not compulsory. You have to follow the strict this rule. Okay, so you can assign any, but you have to mention, okay, this is the assignment, state assignment. Okay, now according to this this 0 0, it is A. So I can write here A. So it is going A to A, right? Again it's A. 1 0 is, you can check here from A, it's B, right? 0 1 0 1 it is C. 0 0 is A, right? 0 1 is C. So I'm writing here state, so easily I can draw the state diagram. Then it is 1 0 is B, so it is going from C to B. 1 0 is B, right? So 0 1 is C. So do not commit any mistake here, right? If you commit any mistake here, obviously your question is wrong. So just assignment, you have to take care during assignment. 0 0 1 is C, right? And this is D, and this is D, right? Make table a little clearly. Okay, now you have to show the transitions. Okay, so I consider here a state like this is a state A, this is A, this is so I write here A. Okay, this is B, I have considered here C, and here I consider state D, right? So this is state D. So I am just trying to draw the state diagram. Now input is either 0 or 1. Okay, so suppose 0 is represented by solid line. Okay, so 0 represented by solid line and 1 represented by dashed line. Okay, so you can use different notation also, when you are writing input and outputs, so you are writing input first then oblique output, like that. So in that case you can use solid lines only, but for the trellis diagram this convention is very useful, or this is commonly used, right? So that's why we are representing this way. So now see how we can draw it. So at state A, when input is 0, right, you are going to A itself. So when input is 0, we are considering solid line. So we will represent with solid line. We are going from A to A. Okay, so I go from A to A. Okay, I'm going from A to A at 0. So I represent by solid line. Okay, at that time what is the output? 0 0. So I write here 0 0. Now when input is 1, in that case we are going from A to B. A to B, but at this time we will represent this by dashed line. So what is the meaning of dashed line? It means that data input is 1. Okay, and at that time what is the output? Output is 1 1. So I write here 1 1. Okay, so one state is completed. From A, 2 transition are there. Okay, so for one transition corresponding to input 0, other transition corresponding to input 1. Okay, similarly now we move to the state this 0 1. 0 1 is C. Okay, so on the C you can draw any state. Obviously there are 2 transitions from each state. Okay, if you want to complete from B, you can complete from B or C. Okay, so at C you can observe, at C it is going from C to A when it is 0. So C to A, it is coming C to A when 0, so you will use the solid line. Okay, transition this. What is the output at the time? Output is 0 0. So output is C to A, sorry, 1 1. 1 1, not 0 0. So output is 1 1. So that you have to keep in mind. So when you can here observe output is 1 1. Okay, second transition is C to B. C to B. Okay, and now it is transition shown with the dotted line because it is at 1, and what is the output at the time? 0 0. So you mark 0 0, right? In the same way, now 2 states are completed. B, so it is going from B to C when 0, B to C. So B to C represented by solid lines. Okay, so you have to show the transition also, and at that time output is B to C, output is 0 1. So cross check once again, it's a 0 1 or 1 0, or maybe that. In the same way you can complete the diagram. Okay, so this is the state diagram. I think you can easily draw it. Okay, so you have to cross verify whether you have drawn the C1 C0 correctly, you have calculated these, and according to you have to put these values, output values, right? So I hope now procedure is clear how to draw it. Okay, so state diagram is clear. So here little correction, it's not a 0 1, right? You can check, it's a 1 0, right? So you have to do that. It's a 1 0. So here it will be 1 0, right? So here it will be 1 0. So you can cross check it. Okay, it's a 1 0. So it is a state diagram. Okay, so I hope state diagram is clear. Now with the help of this state diagram we can draw the trellis diagram. So trellis diagram is the alternate representation of this state diagram. Okay, so we can draw that. So just to check that, let's see how we can draw that. So for that, what you will do, you will simply write the states, right? So I am drawing the trellis diagram, right? This is the state diagram. So in trellis diagram we write the states. So A, B, C, D, right? And after that we put the nodes. So this is node. So you can put as many as, right? So next node I will start from, because we are drawing it in time like that. Okay. So obviously when transition will start from A, so it will go to either B, C, D, anything. So it will go to the next node, not in this, because it in time, right? So like that. So this is B, okay. And for the C, again from B, okay, from B it is go either next node, but from A it come to C here. So when we will see the transition, then we can draw it. Okay, so in this way we can draw. Now we try to draw the transition. So from A you can check here. From A, when input is 0, this is when input is 0, you are going to this, okay, 0. So we can say from A you are going to A when input is 0. Again from A to you will go A, right? Output is 0, 0. So you can complete this like this. From A you are going 0, 0. Okay, 0, 0, and this is and so on. When input is 1, in that case you are going B. Okay, so you will draw from A to B, that is represented by dashed line. So A to B, at that time what is the output? 1, 1. So you write 1, 1. So from each node you will show this output is 1, 1, like this, 1, 1, whatever node we have. So from that node to use, so next node is going to B, like this. Okay, 1, 1, 1, 1. So one state is completed. Now come to the B. From B we are going to D and C. Okay, so when going B to C, so you will go B to C. That means next you will draw here. Okay, at C, because it is in time, so you will draw nodes here, here, and B to C. B to C, and this B to C is represented by solid line 1, 0. So you can again continue this, and this is 1, 0, 1, 0, 1, 0, 1, 0, right? 1, 0, and so on. What is the next transition? It is B to D. Okay, B to D, and it is 0, 1. B to D. So B to D, you have to show B to D. So this 2 you have to represent here. Next node is here, because B to D you are going. Okay, so you will represent here. So nodes. So all nodes in a single column like that. Okay, so B to D, and that is represented by dashed line. So you will represent like this, B to D. What is the value? B to D, it is 0, 1. Okay, so it is I can write 0, 1. Again this is B, so B to D. Okay, this is 0, 1. Again B to D, 0, 1, and B to D, 0, 1. Okay, like this. Okay, so 2 nodes are completed. Now come to C. C, from C to B, you are going C to B, and for solid line you are going C to A. C to A, solid. Solid representing 0, right? So when input is 0, then it is going C to A. C to A, 1, 1. So C node is where? It's here. This is the C node here. So C node is here. So you are going from C to A. So C to A. So this is C, and you have to go C to A. So in time, this is the line. So you have to move from here to here at this point. Okay. So C to A. So C to A you will go. So I am taking another color, so you can easily identify. So C to A. So C to A. from this line to next node is this one. So you will connect this from here, and C2A, it is solid. C2A is solid. So I will connect it like this, C2A, right? In the same way, C2A, this is node, C2A, C2A, like this. And what is the output at that time? You can write it is 1 1. So it is 1 1 1 1 1 1 1 1, right? And again C2B for 1, C2B. So C2B represented by dash dash. So C2B. So C2B represented by dash dash. Okay. So C2B represented dash dash and value is 0 0. Represented by dash dash, value is 0 0 0 0. And C2B 0 0. Okay. The last one is D. So you are going from D to D, and other is D to C. So D to C, D to C. Okay. And it is D to C is solid. D to C solid line 0 1. So D to C, D to C. So D to C is this one. So you will move from next actually. You will not connect here to here. You will connect in time. So you have to go to next. So it is solid, and output is D to C 0 1 0 1. So in the same pattern you will connect all 0 1 0 1 like this. And last is D to D. D to D 1 0. That is dashed. So D to D, it is dashed 1 0 1 0 1 0, and so on, right? So I hope now trellis diagram is also clear how to draw it. So practice all these things, right? So correct any error if it is occur, right? Obviously it is a little complex kind, right? Very near I have written the values. So but I hope now concept is clear. Okay, this concept is clear. So how to draw the state diagram, how to draw the trellis diagram. Okay, it is clear. Now other things are simple. You can see here. So you have to comment on the code rate. Okay, code rate. There are two additional things. One is code rate, other is constraint length. Okay, so code rate is simply how many input bits are there and how many modulo 2 adders are there, right? So here are 2 modulo 2 adders we have. One is input, so code rate is 1 by 2, right? Constraint length. Constraint length is depend on the, if we represent by k, it is equal to the number of memory elements plus 1, right? So I am considering this based on the Dr. A.S. Gandhi sir book, right? So number of memory elements plus 1. So here we have 3 memory elements plus 1, therefore we have 4. Okay, so in this way you can find this constraint length. Now you have to determine the encoder output produced by the message sequence. Here you have to find the encoder output, right? What is the output? So you have to find, suppose in the same way you can do it. Suppose this is C1, this is C0. You can put here it is Q0, it is Q1, it is Q2, right? And here you can write it is a D again. So you can write again C1 is D modulo 2 Q2, right? 4 lines are coming here. Modulo 2 Q1, modulo 2 Q0, right? And C0 again you can write what value you are getting. So in the same way you can represent in this way, and you have to find these values. So here only the concept is that this message sequence is basically like this, dot dot dot, right? So we are first receiving this 1, then we are receiving this 0, then 1 1 like this. So here you will apply this in this way, 1 0 1 1 1, because we are getting further, right? So whatever value we are getting, so first you will enter here 1, corresponding to that you will find C1 and C0, then you will enter 0, correspondingly you find C1 C0 like this. So I hope this is clear. Okay, so now question 1 2 is clear, and now you can check in this also. So again here what is the code rate? 1 input, 3 modulo outputs, right? Modulo 2 adders, so 1 by 3, right? Constraint length k 3 like this. So you can find Now you can draw the state diagram, Trellis diagram, what I have discussed. So I hope you can do that. Okay. So in the same way, you can connect the question 4 can be solved. Here, don't get confused. Whatever is written here. So again, this is the output of D1. Okay, and D1 connected to D2, and this is the output of D2. This is the output of D3, like that. So in the same way, you can solve all these questions. And here, some equations are given. So by using these equations, you have to draw the circuit. So simple. This is dk minus 1, dk minus 2. So if this is the flip-flop, you are providing here input. So suppose this is dk, right? So its output will be dk minus 1. Again you put one more flip-flop, then its output is dk minus 2, right? And so on. Like this you can connect, and one modulo adder you can connect here. We have the two equations. So other modulo 2 adder you can connect here, right? So you can connect it here, you can connect it here, connect it here. So we have here dk minus 1, dk minus 2, dk minus 3. You have to connect one more flip-flop also. That's the output you will connect. So in the same way you can draw the circuit. Okay. So I think now you can solve all these questions, right? Still, if you have any doubt, you can comment me. Okay. So try to solve these questions. Thank you for watching.